In this video, we're going to look at an example of using standard reduction potentials and equilibrium constants and the relationship between them to find a new standard potential. So the basic idea here is that if we have two different half reactions that we know standard potentials of, so half reaction 1, we'll have a E naught for the positive reaction minus half reaction 2, where we have the negative standard potential. Overall, we'll have a E naught total is E naught plus minus E naught minus, and that is directly related to the equilibrium constant for the total reaction, which we just derived in the last video. K equals 10 raised to the n E naught over 0.05916. So we have three different pieces of information. We have E naught for the overall reaction, or K. These are directly related. We can find one from the other. We have E naught for the positive half reaction and E naught for the negative half reaction. If we know 2 out of the 3 of these, we can find the third. And that's the basic idea using this equation right here. So let's go through an example of this. So we have we're going to look at a few reactions here. So let's say we're looking at this reaction. Nickel ions complexing with glycine, 2 glycine minus, to form this complex, this nickel-glycine complex. All right, and let's say we know K for this reaction. 1.2 times 10 to the 11th. So very favored to form the complex. And let's say we know E naught for this reaction. And this is one we can just look up. Nickel 2 plus 2 electrons to go to nickel solid. And E naught we can look up in our textbook or any table of standard potentials. And so we have 2 pieces of information. Let's say the question is, what is E naught for this reaction? Where we have the nickel-glycine complex being reduced to nickel solid plus 2 glycine minus. All right, and so that is what we're trying to find out. So for the 3 pieces of information, we know K, we know E naught for one of the reactions, and we don't know piece number 3 here. Okay, so the first step here is that we need to know how are these reactions related to be able to look at this. All right, so if we write our reduction of nickel reaction here, okay, that's one piece, and we're going to need to think about how these are related. Well, if we also include this reaction, our first reaction, that's not on the screen anymore, right? This first reaction, nickel plus 2 glycine goes to nickel glycine 2. That's going to be our total reaction, right? There's no electrons involved here. So let's say we have nickel plus 2, and then we have our unknown reaction here, our unknown reduction. Nickel glycine 2 plus 2 electrons goes to nickel solid plus 2 glycine minus. Okay, we know that our final reaction is going to need to be our nickel 2 plus 2 glycine minus, forming our complex. Right, these are the three reactions we know about. Okay, well, if we look at our reactions here, if we added this together as is, obviously we wouldn't get this to work out. So this one needs to be our negative reaction, because this nickel-glycine complex, while it's a reactant here, in the final version it's a product. So we need to subtract reaction number 2. That's going to be our oxidation. So this will be E naught plus, this is going to be our E naught minus, we know this one, This is our unknown. And we know K for this reaction, which allows us to find E naught total. All right, so let's go ahead and go through this. All right, so we can use, so let's do this step first. All right, so we can use the version of the equation where E naught is equal to 0.05916 volts. In this case, N is equal to 2. We have 2 electrons involved in our reaction. Log of K, and K here is 1.2 times 10 to the 11th. If we plug that in, we get that E naught from that K value is 0.328 volts. And overall, we need that value, 0.328 volts, which again is E naught total, will be equal to E naught plus minus E naught minus. But we know E naught plus is equal to negative 2.36 volts, negative 0.236 volts, minus E naught minus. And then we just need to reorganize this equation. All right, so what we'll get is E naught minus is equal to negative 0.236 volts minus 0.328 volts. And so overall, we get that this is equal to negative 0.564 volts for the reaction that we're interested in, which again is this reduction of the nickel glycine complex right here. Okay, so this is an example of how we can use these bits of information to find things about new reactions. This is a little bit like with thermodynamics when we have, say, delta H values and things like that. But now we can do this with standard potentials, and we can use known values like the reduction of nickel. That's a very common reaction and something you can easily look up in a standard reduction potential table to be able to address a question like this.